Hello everybody, in today's video we're going to be looking at our fall and winter discussion for 2021 into 2022. Yesterday we had part 1 of this video where we mainly talked about what a La Nina would mean for the United States and Canada, and now we're going to be mostly looking at partly what a La Nina would mean for the United States and Canada, but we're mostly going to be talking about some of the upper air features that some of the longer range models are forecasting. So if you haven't already, I recommend that you go check out part 1 of this, and then again come back to this video and then watch this, because some of that is going to tie in, and you're going to need to know some of the background information of what we talked about yesterday to figure out what we're talking about in today's video. And again, one of the reasons that I didn't do this all in just one big video is because if I were to do that, it would probably take, it would be probably a 40 or 45 minute video. So I want to kind of split it up into two. Therefore, you guys have 2 days of content, and it would be a lot more. I would be able to expand on some of these topics a little bit more than I would have if I was only doing this in a 1-part video. So let's start off with yesterday and just kind of recapping what we talked about in the last video. We're going into a La Nina most likely for the winter time frame, which you can see is right from here to here. So you can see that we're below that La Nina line. And so we're going to be in a weak or maybe borderline moderate La Nina. Normally what that would mean for a lot of areas is that you're going to see some cooler temperatures into the northern plains, the northwest, also into western Canada, and that will also extend all the way down into these areas as well. Now, there's a little bit of discrepancy. How far south does this jet stream kind of just linger around? And then also, does this just kind of cut off to the east, or does it curve up before heading to the east coast? Both of them will have huge impacts on the outcome of the winter. So if we're looking at where I'm most uncertain, it's going to be for the coastal northeast through the mid-Atlantic and then also into the Tennessee Valley. So this area is where I have the least confidence right now in the winter forecast. The rest of the United States, we're fairly certain on what could happen. Warmer and drier normally what happens if you live in the southern third of the country. Now, again, like I said yesterday in the first part of this video, even though on this map it says warmer and drier, this is a typical La Nina winter, and just because it's warmer and drier as a majority of the winter, let's say 2 out of 3 months of winter are warmer and drier, you could still have one active month that maybe you get one snowstorm, maybe you get one snow event in the southeast or in the southern plains. That would completely change the outlook on the winter. And again, that happened last year with that Texas snowstorm. The rest of the winter was fairly dry. We didn't see too much activity down there. But then we saw that 1 to 3 week stretch where it was really cold, and we saw that snowstorm ride along through that stretch. So, of course, you have 1 or 2 weeks that go completely awry and go on the opposite trend of what we were expecting, and that'll completely change the winter. So even though it says warmer and dry, that does not mean that you have to let your guard down, because of course we do still see snowstorms and snow events even that far south, even in a warmer or drier pattern. It's usually more active if you live in the Ohio Valley and the Tennessee Valley. But that is going to be wholly dependent on whether the jet stream curves up at the end of it, or if it just kind of lays low and moves out to the mid-Atlantic coast and then eventually curves up. That'll have a huge impact on where the most active area is. Usually this does not change at all depending on where the jet stream is. This usually is a fairly set in stone thing, but the northwest is usually wetter, or depending on your elevation and depending on the individual storm, potentially snowier than normal. So one thing that we want to talk about is that we have been experiencing some drought in the western United States, and it looks like, depending on where in the west you are, you might be dealing with a little bit of that drought being relieved. So you of course see that we have those high amounts of drought into the northern plains and also into the west. These areas into the northwest and into the northern plains, I'm pretty confident that most of that will be relieved come the fall and winter time frame. So we're expecting a good amount of moisture, especially for the fall and winter time in especially the northwest, but also maybe even lingering into the northwest, into the northern plains, and then also into the southwest. That's where I think it's probably going to stay a little bit drier. You're not going to see as much rainfall or snowfall. So That is bad news because these areas definitely need the rainfall. Areas like New Mexico and Arizona are starting to relieve some of that drought, but still areas like California, Nevada, Utah, even into parts of Colorado and Wyoming still need some of that drought relief, and it doesn't look like you're going to get too much of it, especially with how the winter is expected to go down. If we look at the August predictions for La Nina and what the following winter brought, you can see that all these blue dots are the La Nina year. So you can see right here, this is by the month of August. Here's what we were expecting in August, and we were expecting a La Nina in all of these years. Now, this is the effects of what actually happened is kind of where the dot ends up. So if the dot is higher up, that means that it was a more active winter for the Southwest. If it was further to the bottom of the screen, which you see for the majority of these blue La Nina dots, that usually means that it was a drier winter and also that it was a colder winter. So you may be dealing with a dry and cold season for the Southwest. Now, of course, we have those outliers, which are these three dots right here, where we were expecting in August to have a La Nina, and we ended up with a warmer or even a wetter active season in the Southwest. So that, of course, is a possibility. It looks like either way it's going to be cold, but how much precipitation still on the table and still definitely something that we have to consider. It looks like most of these areas, most of these dots here fall between that 50% and 100% of normal precipitation, meaning that you are probably slightly or even moderately below normal for the entire season. So that's not good news for them, especially considering that the majority of the La Nina years are going to be drier in that area. So hopefully we can get one or two big storms that can kind of moderate some of that, but it doesn't look too likely as of right now. If we look at the forecasted map of the United States from December, January, and February, so an average out of the precipitation anomalies, you can see that especially over that southern third of the United States, we're expecting it to be drier than normal, and then into the northwest and the northern plains, as well as parts of southern Canada, we're expecting it to be much more active than normal. That also extends down into the Ohio Valley and the Great Lakes, and then again, even this model is a little bit more confused on the Tennessee Valley and the Northeast. You can see how it has it kind of in a blank color. That either indicates that they're expecting it to be near normal, but in most cases that means that they don't have a lot of confidence. That means that most of the models in that averaged out ensemble are kind of all over the place, and so it average out to be near normal, but in reality, it's kind of just showing confusion within that ensemble. So we'll have to see. Again, that area is where I have the least confidence right now, and usually that's the area where you're going to have the least confidence in most years, just because of how storms usually bring snowfall to those areas. If we look at the temperature forecast, and I don't usually take this with any sort of confidence, or I really don't look at this too much. I usually look at the upper air maps, but I just want to show it to you just so you guys know. Last year, if we were to look at the same model, it would have said the exact same thing. So usually you're never going to see a winter where the entire United States is warmer than normal. That is very, very rare. And most of these long-range models, they're always going to show this. Most of them have a warm bias. So I would look at where it's not as warm, and that would kind of be the outline of some cooler temperatures. You can see that there's a little bit of higher anomalies into the Southwest, and that might be some kind of an indication of a little bit of high pressure. And if that were to be the case, then you would have colder air into the east. But again, this is not a good map to look at, and I'm going to show you why when we start to look at the upper air maps, because these surface maps, very hard to forecast that far in advance. So I like to look at the upper air maps, which is really where all that cold air or the warm air comes from. You want to follow the low pressures, the high pressures, and everything in between, and that's how you're going to figure out whether it's going to be warmer or cooler than normal, not by looking at some surface map from a model that usually has a warm bias. So this is the European model. and this is its forecast of the polar vortex, and this is just over the next 10 days. So this model came out, and it was last run September 3rd, which was 2 days ago. So you can see this is what it looks like now, and what the current polar vortex generally looks like. And you can see it's nice and wrapped up on the left hand side of the screen. It's nice and wrapped up, and there's not too much disruptance within that polar vortex system. If we look at for September 14th, which is on the right hand side of the screen, this is the last day of this model run, so this is the farthest it goes out. You're already starting to see that not only is that polar vortex expanding a little bit, but you're seeing two conflicting areas. You have one that's over parts of Siberia and then down through Alaska, and then we have another one which is over parts of Eastern Europe, and also down through the North Pole into Greenland, northern Canada. So that area is where we have the second set of cooler temperatures up in that northern hemisphere region. So you're dealing with, in that kind of Arctic Circle, that's where we have your polar vortex normally. And what we're seeing is that even this early on, the polar vortex is already starting to shift around. What we saw just a couple of years ago when we had a really warm winter for many areas, and we had a fairly snowless winter for most of these for most of these areas. What we saw is that we had a wrapped up polar vortex, pretty much in a perfect circle, and that kind of just sat there in the Arctic Circle, did not move a lot. And usually that's going to mean that you're not going to see too much in the way of cold air, and without cold air, you're not going to see too much snow. So what you would want to see, if you like cold and snow, is you would want to see early on this polar vortex already being disrupted. When it's in kind of split in two, or when there's kind of some disruptance within that system, that means that it's more likely to dip down into the United States, and then have another part of that dip down into Asia and Europe. And that's usually what we consider a polar vortex split. That's when you start to hear all these headlines of polar vortex coming down into the United States and all of that. So that's when we usually get the coldest temperatures. That's usually when we get a snowy outbreak. That's what we saw last year. The polar vortex for December and January was showing signs of maybe breaking apart or collapsing, and then eventually in February it did, and then you saw that big snowy winter for parts of the Northeast and the Great Lakes that February. So the polar vortex definitely is one of the biggest factors, and I like to look at it, even if it's only going out 10 days. You can definitely look at some of the longer range models for the polar vortex map as well. And this is at the 10 millibar level, so it's way up in the atmosphere, but this is a good indicator because this is not going to change a lot. It's not going to change model run to model run, and you don't see too many biases from the models pick up at that 10 millibar level. So it's really a good unbiased way of looking at what we're expecting, and especially if you know what to look for, you can definitely get a good idea of what to expect come wintertime. Now let's start looking at the CFS model, which does have a warm bias, so you're going to see some of that pull up in that 500 millibar map, but it's a lot less noticeable than when you look at the 2-meter temperature anomalies, and you see the entire continental United States and Canada is under fire with the warmer than normal temperatures. It looks like it definitely has a warm bias. So when you look at the upper air maps, it's gonna kind of run out that bias, and you're gonna start to see a little bit more of an accurate map take place. So this blue line right here, this is the freezing line in the upper atmosphere right here. So you can see by December, so we're looking at the average out for December, we have that dipping down into the northeast a little bit, but definitely not too far to the south. And it looks like December for a majority of the west and maybe the central United States as well, with some exceptions, is probably going to be a little bit of a warmer month. But good news if you want a white Christmas where you have snow on the ground for Christmas morning, it looks like by January, at least by early January, it's going to switch. So could that switch happen in late December? Definitely a possibility. And if it did happen in late December, then we could of course see some snowfall on the ground for a lot of areas. So again, a white Christmas still definitely definitely a possibility, especially when you see that by January we have a much colder pattern. what we see is that we have a low pressure dipping down, and this might even be indicative of a polar vortex split. I would have to see the entire hemispheric picture where you would be able to also see Europe, but it looks like we have at least one split in the polar vortex. One of them goes down into Quebec, Canada, and that dips the jet stream all the way down into the eastern United States. And one of the reasons that also happens is because we have a big ridge up into the northwest. So when you have a big ridge on one side of the country, you're going to probably see the opposite on the other side, because it kind of has to even out, and you have to get equilibrium within the atmosphere. So in order for that to happen, you're going to need to see a big trough into the east if you have a big ridge into the west. So you have that big trough in the eastern United States. It'll probably be really warm into the west by that point. It will probably still be active, especially if you live in the northwest, but probably a little bit more in the form of rainfall. And then again in the east, we have that jet stream dipping down. And what's interesting is that you don't see that polar vortex maybe into the Midwest and northern plains, where you see that dip into the central part of the country. You see that going all the way down along the east coast, which would be a good sign if you live in parts of the lower Great Lakes, the Ohio Valley, and then into the mid-Atlantic or the coastal Northeast. If you want snowfall, if you live in the interior Northeast, you would want to see more of that Midwest colder air, because you would still get clipped with some of the snowfall from that. So two different competing interests. And also, if you live especially in the Tennessee Valley, even in the Southeast, this would be a good sign for you if you like snowfall, because you would have potentially 1 or 2 days where that jet stream dips all the way down to the south. And when that happens, you of course have the chance that a storm passes through and maybe brings a couple inches of snowfall. So of course these are all hypotheticals, but something that you want to look at, and it's definitely a lot more intriguing what we're seeing on the models than what we were expecting just a couple months ago. If you look at for February, this is when it starts to shift a little bit, and I think a lot of the country by this point is going to be in that colder than normal pattern, except for that southern third of the U.S. where it looks like for the majority of the winter, you'll either be near normal or a little bit warmer than normal. So again, this is for February. You can see that we have that ridge, and what happens is that it moves a little bit offshore. So now instead of being over the mainland United States in parts of Washington, Oregon, Idaho, Montana, it's now off of British Columbia. So that means that this entire low pressure system has to kind of move further to the west. It continues to expand because we have a high pressure overhead over the Arctic Circle. So this low pressure is completely encapsulated. It has absolutely nowhere to go. So now you have this colder air dipping down into a majority of the country. Even though that 540 freezing line in that kind of blue line right here is still up to the north into parts of the Midwest, the Great Lakes, also into the Northeast, again, that is going to dip down every once in a while, every week or so. It's going to dip down a little bit further to the south. So this is an indication that we could be seeing a polar vortex split. And what's good news, if you like colder and snowier conditions, is that it looks like it'll probably happen sooner than what we saw last year, where it happened in February. Maybe now it happens in December or January, which is of course a real possibility, considering that even in September we're seeing some signs of a little minor split in the polar vortex. Now what you see at the upper air maps and the polar vortex maps, that's going to happen usually about 3 weeks after at the surface. So if you're looking at a map and let's say on September 1st it says that the polar vortex splits, which it does not, but just as a hypothetical, if it says on September 1st that the polar vortex is going to split, you're going to want to wait until September 21st, 3 weeks after, or about 2 or 3 weeks after, to actually see that split come down into the eastern United States. So you might be looking at some of these polar vortex maps at the 10 millibar level and say, wow, that polar vortex looks like it's over Canada or the United States by that point, and it's still maybe near normal. It's not that chilly in your area. You're going to want to give that 2 or 3 weeks, because it's at the 10 millibar level. It's way up in the atmosphere, so you're going to need to wait a few weeks, a couple weeks, for that to actually materialize down to the surface. So even if we see that polar vortex split by December 1st, we're still going to have to wait until late December, maybe January, to actually feel any of the effects from that. If we look at the CFS model and its polar vortex 10 millibar temperature map, you can see these are the actual temperatures, and once you get into that blue color, that's generally where you have your polar vortex located. You can see that as we get into December, still fairly well located, but what I am seeing is a little bit of a tug on the southern side, so that could be the early signs of maybe something splitting off on the southern end of that, but it still looks like a fairly wrapped up system as we get into December. Then as we get to January, you see how it kind of migrates a little bit further to the south, and you can see how elongated it is. It's not in a circle anymore like it was just a couple of years ago, where it was much warmer into the United States. Unlike what we saw last year. Last year, it was also elongated like this. And that is definitely a sign that even though the averaged out map, again, even the averaged out map, this is for the entire month of January. So you're not going to see any huge anomalies. You're not going to see the full split on this map. But when you see it kind of stretching out a little bit, you want to take note of that, because that could be a sign that you're seeing the early signals of a polar vortex split. And you can see how stretched out it is. It's in an oval shape by this point. It's no longer in a circular shape, which would indicate more strength within the polar vortex and more of a stable polar vortex. If we look at for February, you can see that the polar vortex is weakening, and you would want to see that because a strong polar vortex would kind of just wrap up into the Arctic Circle. It would create a very, very cold Arctic Circle temperature pattern, and we actually saw, I believe in 2018, I might be mistaken, 2018 or 2019, it might have been the 2019-2020 winter also. But we saw the most ice cover since 2012 into the Arctic Circle. And the reason that is because the polar vortex stayed over that area for the entire winter. So that's what a wrapped up polar vortex can do. And what we're seeing here is a little bit of a weaker one that has the potential to migrate into Asia and Europe, as well as into North America, especially when you're starting to see these lighter blues pop up, where it's definitely not as strong as what it was earlier on in the model run. So that is going to wrap it up for today's video. If you have any questions, leave a comment down below. If you want a personal forecast for your area, it doesn't even have to be about the winter or fall. If you just have a storm that you want to know about in your area, leave a comment down below as well. And I'll see you guys in the next one. Goodbye.